Hi guys, welcome to the second part of the FXGL 3D tutorial. In this one, we're going to add three things. We're going to add a random spawn mechanic for the so-called crystals. Then we're going to add some camera effects, like zoom or kind of move around stuff when we catch a crystal. So there's going to be some kind of a camera animation. And number three is going to be a new 3D shape. So that should give you some ideas for your own games. First of all, I'm going to change the FXGL version from developer to 11.15 since it's released now, and it's usually, well, it's fine to stay on development version, but some things may change. So it's easier to stay on the stable version. Okay, so that's done. Now I just need to make sure that this still works. Right, so this is what we had from last time. We're able to collect these things. If we do collect them, the score goes up. If we don't collect them, the score goes down. So how about we spawn these things at random? That was one of the suggestions from the last video. That is actually going to be quite simple to do, because this is where we spawn the platform. This is where we spawn the crystal. So instead of spawning it at 0, 0, which is X, and so X and then the Z, Y stays the same, so it's the same height, but we want to change X and Z. What we could do is just obtain a 2D point, because technically X and Z values give us a two-dimensional point, and we can use FXGL math for that. We can get a random point in a rectangular bound. Yeah, let's use that. Rectangle 2D. So we start from -5, and width and height are 10 and 10, which means the rectangle goes from -5 to +5. So anywhere in that rectangle, there will be a point that is a valid point. So that's the point that we're getting from this function call. And then using the X value of that, we can use the to set the X value of the spawn point for our crystal, and we can use the Y value of that point to drive the Z value of our crystal. Let's try that. So they are now spawning in different locations, which is good. This perspective is only useful for some of the collisions, because I can't really feel the depth, so to speak, for certain collisions. But anyway, so next thing to do is I like some kind of a camera effect. Like, imagine we're going to collect a crystal by colliding with it, and then at that moment the camera kind of zooms in on the platform and the crystal, and then zooms back out. So that's going to be a translation animation, because we're not going to do scale or rotate aspects. We're just going to move the camera in and move the camera out. And if we were to do it linearly, it will still work, as in you're moving it at the same speed every frame. But we have one of the animation system that we've got in FXGL is quite powerful. So we can use that and its interpolators to drive the camera movement. And I'll show you how to do the general animation, so you don't kind of, it's not going to be specific to just camera. Using this method, you're able to then animate anything you want. So where do we collide? This is where we collide. On collision begin, crystal and platform. So at that moment, what I'd like to do is take the camera and just move it close to the platform. Do we have a camera reference? No. Camera 3D. Okay, let's take this out. Camera 3D. And let's just call it camera. And this is the reference that we get. So it's now initialized and all good, we can access it. All right, so what we're going to do here is animation builder. We're going to animate. So you can see that you can translate, you can rotate, you can scale, fade, and so on. You can even do color animations. But these are specific to entities or nodes. Camera is neither of them, which means we can't call these functions directly. However, there is a general case version, which is called animate. Using the animate function, we are able to supply an animated value. In our case, it's animated point 3D, but you can see from the drop-down, IntelliJ gives you some examples. These are the built-in examples that you can use. Or you can just define your own animated value from T to some T type, T being the generic type. Let's use animated point 3D since we're moving in 3D space. We're going to move, so we need to supply the from and to. The from is where the camera currently located. Let's just see where the camera actually is, because I don't know. I want to hard code this because I don't want it to take its current position. Otherwise, we might get stuck in a loop with just moving in and out. So let's just print where the camera is. Camera, get transform, get X, get X, get Y, and get Z. I'm going to use those values as the point, as the starting point. So it's 5 minus 10 minus 15. Yep, that's good enough. So we're going to animate our animated point 3D. The from value is going to be this one. 5 minus 10 minus 15. The to value is going to be the position of our platform. Get position 3D. But it's not the platform's position per se that we want. We want to get close to the platform, but we don't actually want to set camera position to the platform's position because you won't be able to see anything. So what we could use is the direction and then do some vector maths. First, let's obtain camera direction, which is a vector, and camera get transform get direction 3D. So the camera direction vector is a three-dimensional vector that points at the point where the camera is looking. So it's your directional vector that comes directly from the camera to the thing it's looking at. Is that what we want to use though? Okay, let's have it here for now. At least you now know if you need to do something with direction 3D, then you can use that. But actually, I'm thinking that we might not need it because we already have the location of the camera, we have the location of the platform. So what we can do is just get the vector from the camera to the platform, move the camera along that vector, say about 90% of the way, that means it's going to get close to the platform, but not actually reach it. So the vector is, it's that minus that. So it's platform, get position 3D, subtract camera, get transform, can I just get position 3D. So that gives us the vector from the camera to the platform. And what we'd like to do is to take the distance. So we know the distance is the length of the vector. The length is also called magnitude. And then multiply it by something like 90%. We can then scale the vector. Vector, normalize, and then multiply that distance. So what we've done here was we obtained the vector from the camera to the platform, the entire vector. We took its distance and shortened it so that it's 90% of the distance. And then we reduced the vector to that 90% here. Normalize means bring the vector to unit length. And then by multiplying the distance, you can make it so that the length is the value that you set, which is the distance. So now we've got this vector. All we need to do is add it to this point. Add vector. So this is going to animate from this point to that point. On progress is how you supply whatever it is that needs to be done on progress. So it takes, well, it gives you a point 3D, which is the animated value between from and the to value, which you can use for any purposes. And that point is what we're going to move the camera to. Camera, get transform, set position 3D to this point. And then we just build and play as per usual. Now just realize that this is still taking the current position of the camera. We should use this as the point, so that it's hard-coded, so that it's a fixed point in space rather than the camera's current position. You now know how to use camera direction, so I'm going to get rid of that. Let's see how this works, shall we? So I just need to collect something. Nice. That is actually much better than I thought it would be. Now we just need to bring the camera back. And for that, it's, well, good news is we don't need to do much. We just say repeat this animation twice, and we say auto reverse true. That basically means do the animation once, but when you're doing it the second time, reverse the animation, so it's going to go back. It's going to alternate between odd and even numbers. So if you're doing it 3 times, it's go in, go out, go in. And we'll introduce an interpolator at some point. So it's doing that. I think we need to set to 0.8 because 90% is too close. And we might want to reduce the duration of the animation. Yeah, that's slow. We need to make it quicker. Duration 0.3 seconds. By default, it's 1 second. Maybe 0.5, I don't know. Yeah, that's not too bad. 0.4, shall we say, so that we can actually feel the difference for the interpolator that I'm going to introduce. Which we have plenty of interpolators that are built in, and depending on what kind of effect you want to achieve, you just pick one. Usually you just pick something and then you see how it works, kind of thing. Exponential is usually quite good for translations. It kind of gives you this smooth effect. Let's try that, ease out. Nice. That's pretty good. So you can see that the animation is still the same. It's the rate of the animation that is different. We're still starting and going to the same value, and where the duration is exactly the same. So everything else is the same. The only thing that's different is the rate of the animation, how fast we're moving through the animation. Or through parts of the animation, because the entire length, the entire duration is exactly the same. And that's great about animations in FXGL. Well, I suppose in any other game engine as well. Right, so that was the second thing that I wanted to introduce. Now the final thing we're going to do is we're going to go to the factory. Why is that red? Fair enough. It's just saying it can't find this function while still compiling and working just fine. It's probably just the IDE having a problem somewhere. Anyway, we're going to introduce a new 3D shape. It's going to be a generic-ish shape. It's a prism that you can use for various purposes. So let's call this... I actually don't know what it's going to do to our gameplay. So let's just call it Prism. Maybe we'll just add it somewhere in the background. It's going to just rotate or something. So material, let's make that dark green. We don't need bounding blocks. It's not going to be collidable. The type really doesn't matter. So it's just going to be the view. And the view is going to be the prism, which comes from this package. Where is it? This one. This is the package that's going to store all 3D shapes in FXGL. Okay, I'm just trying to figure out the constructor. So it's got bottom radius, top radius, height, and number of divisions. You can also construct it just without any parameters, and you can just set the parameters from method calls as well. So let's set height to something like 4, so it's going to elongate the shape. And that is good enough. So let's go back to our Crystal app. We're going to spawn it here somewhere. We don't really care too much about this thing. It's going to spawn Prism at... We're going to push it to the left side, -5. The height is -4, and then push it forward, so it's something like 7. And then we're going to animate it as well. We're going to rotate Prism from. So you can see that there are two functions called from. One is for 2D, which is the start angle, because in 2D there's only one axis along which it makes sense to animate or rotate. It's the Z axis, because you're rotating that way. You can rotate, I mean, you can rotate along X and Y, but it doesn't make that much of an interesting difference in 2D. In 3D, it takes not angles, but a point 3D, which contains in itself the X, Y, and Z values, which are the angles along these axes. So we're going to start from 0, 0, 0, which is the default, but we are going to rotate to, so if we want to do it that way, it's the Z axis. So we're not going to change the Y values or the X values. We're going to change the Z to 180. So it's going to do like this, and then it's going to come back. Build and play. Why isn't there a build and play? It's weird. Something's gone wrong with my IntelliJ installation, because build and play is definitely a function that is part of this. So rotate from 2. We're going to repeat this animation infinitely, and we're going to auto reverse as well. So it's going to alternate. Essentially more or less the same thing that we just did for the camera. Yeah, so it's there somewhere. Let's bring it down a little bit and then move it to the left. -2, and to the left, -9. Yeah, so you've got this prism with 3 sides. This is the default. You can change number of sides or number of divisions. If you set it to a really high number, you basically get a cylinder and anything else in between. Yeah, that animation, I dig it. It's really nice. Right, so in this video we looked at spawning our crystals in random locations. Then we looked at creating a camera animation, or rather creating a general animation that we can use for animating anything. And we use that to animate between 2.3Ds, allowing us to change the camera's position to one of these points. And then we introduced this prism shape that is just doing its own thing, which you might find useful for adding new entities or some new things to your game. You can play around with its top and bottom radii, as well as the height and number of divisions, so it could be quite useful for building other things. But these are all kind of custom shapes. These are not actual 3D models. And 3D model loading capability will make its debut in 11.16, which is the next version. So look out for that, and I'll be making a separate tutorial afterwards. But for this one, it's pretty much done. So thanks for watching, and I'll see you guys later.